When Benjamin Franklin first flew a kite into stormy skies, he could never have imagined the more than 200,000 miles of interconnected devices that make up our network of electricity today, the power grid. It makes nearly every nuance of our daily lives possible, yet breeds chaos when it fails. Keeping this awesome system in check is the work of engineers who have dedicated their careers to keeping the lights on. Born just months apart in 1937, yet on opposite sides of the globe, Arun Phadke and James Thorp were alike, yet different from the start. As a boy in Gwalior, India, Phadke was so bright that the system could barely keep up with him.
I was too young to join engineering college, so instead I worked towards a science and math degree in my hometown. So once I finished that, then I was of the right age, so then I went to engineering college and finished that degree in '59.
After moving to America and earning his PhD at the University of Wisconsin, Phadke worked in industry for nearly a decade before joining the faculty at Virginia Polytechnic Institute and State University. Thorp took a purely academic path. At age 18, the Kansas native enrolled at Cornell University to study electrical engineering.
I stayed and got a PhD, and they asked me to stay on the faculty. And I thought it would be nice to say you had been an assistant professor once. So 42 years later, I retired.
On a sabbatical from Cornell in 1976, Thorp met Phadke at the American Electric Power Company.
Arun's project, the one that I started to work on, was to introduce these little computers into a situation in the power system where they had electromechanical devices. They're like clocks. And it was clear that computers were going to change all of that.
These electromechanical devices, called relays, protected the power grid by detecting faults in the system. But with fixed settings, these relays could backfire because changes to the system over time, such as increases in load, could be misinterpreted as faults. Phadke and Thorp realized it wasn't enough to just replace them with computerized versions. The fundamental philosophy of how relays operated also had to change.
So the idea came up that there ought to be a relay which says as the system changes, the relays would change too.
Combining Thorp's theory of adaptive relaying, Phadke's work on precise measurements, and the new technology of satellite time synchronization, the men set out to give the grid a total overhaul.
These disturbances are like waves coming at you, and it's like a tsunami coming at you. You can have a tsunami warning system and run for the hills when the tsunami is coming. And electrically, we could do the same.
We put these PMUs, phasor measurement units, with a built-in GPS receiver in each station. Then we get a very precise picture of what's happening in the power grid at that instant.
But the power industry was slow to recognize a need for change. It would take over 2 decades and a number of catastrophic blackouts for them to see the light. In 2004, Thorp came out of semi-retirement to join Phadke at Virginia Tech as head of the Electrical and Computer Engineering Department. There, the pair, who even share the same hobby of painting, continue their perfectly balanced collaboration.
We complement each other so nicely that the partnership has continued sort of indefinitely. Fractals and these kinds of things are what fascinate me about the power system, and I think Arun really wants to keep the lights on. I like to paint abstract things that look chaotic, and Arun has a very regular world where he has landscapes and fruit and all that kind of stuff.
With Phadke and Thorp's work now being implemented in power stations around the globe, a smarter, stronger grid of the future is in sight.
What our work should do is to reduce the intensity of the blackouts that occur and reduce the frequency.
Certainly this is a great deal of progress in a hurry, finally, finally in a hurry.
The 2008 Benjamin Franklin Medal in Electrical Engineering is presented to Arun Phadke and James Thorp for pioneering contributions to the development and application of microprocessor controllers in electric power systems, playing a key role in diminishing the frequency and impact of blackouts.